We are going to start with Newton's third law. And here's the definition of Newton's third law. Okay, this is Newton's third law. Okay, and this is the complicated way of saying for every action there's an equal and opposite reaction. You've heard that one before in cartoons or wherever. Okay, here's how we write it in our equation forms. Okay, it is the force of one object on a second is equal to negative the force of the second object on the first. Okay. So, if two things are in contact with each other, so let's say we have a surface and that's kind of hard to see, isn't it? Darn it. Okay, so here's the surface. On our surface, we have a block. Okay, of mass big M. Okay. And then on top of that block, there's another block. Of mass little m. Okay. So what we're going to do is draw a force body diagram on each of the blocks. Right? So on the big one, okay, or on the purple one, it's going to experience gravity. Big mg. And coming from the table, it's going to experience a normal force. But there's another one. Because now it's got this other block sitting on top of it. And so it's also going to experience little mg, so that the normal force acting on the big block is actually carrying both of them. You guys follow that? That the force on the table acting on this guy has to be enough to support this and the other block. Yeah? Imagine carrying something and it's heavy and you have to carry both things. Okay. The little block has mg on it, okay, but it's not accelerating, which means its forces have to be balanced also. But the only thing acting on it is the other block. Okay, and so it's experiencing its own normal force, but it's the force of, well, let me reword those instead of 2 and 1. It's the force of the big thing on the little one. And this one right here is the same thing as the force of the little one on the big one. Notice that they're in opposite directions, and so that would be the negative. This is the idea behind Newton's third law. Okay? Or there's another one. Okay, new surface. Or let me finish this one out here. Finish the thought. That the force of the little block on the big block is equal to the force of the big block on the little block. Negative. That this thing is equal to that one. You guys see that? Okay, so new surface. New block. Okay, and with these two blocks, they are touching each other. So if this one pushes on that one with the force, so if red force of 1 on 2, okay, it's going to be equal to the negative force of the blue one on the red. Or whatever color you want to do it. But okay, so the force of the red block on the blue one has a certain amount, and that equals the force that this one's pushing back. Okay, these are called a Newton's third law pair, and we're going to see these a lot. Okay, this is a Newton's third law pair, and we'll see these a lot. And so any two objects that come into contact with each other have this interaction. That force might be really, really small, but it's there. Okay. Now, the important thing to know is the pairing does not happen, both of them on one object. They happen to two different objects when they touch each other. So it's not that one object is going to have both forces at the same time. This one is pushing against that one, and this one is pushing against that one. Yeah? They don't both happen to the same object at the same time. Okay. All right. That's really about it. So, let's have okay. Okay. We have two sumo wrestlers. Right? And this is that's Joe, and that's Sarah. Because could happen. All right. They're in the same weight class, so could happen. All right. So Joe and Sarah, and they're pushing against each other. So the way we explain this is Joe okay, if Joe pushes on Sarah, okay, the way we explain Newton's third law is that Sarah is that. That's it. If Joe pushes on Sarah, Sarah pushes on Joe. That is the Newton's third law pair. Yeah? It's that straightforward. It's that simple. Okay? If one thing hits another, okay, the other thing hits back. Okay? Or if if one thing pushes something else, the else pushes back on the one. Yeah? Okay. That's really about it. So if you keep yourselves stuck on this idea that these forces are pushing against each other down here, that they are acting on different objects, right? And in our first drawing, what are our pairings here? That we had this one and this one are the third law pair. Yeah? If these are the third law pair, okay, this is the little block pushes on the big block and the big block pushes on the little block. Yeah? If you keep them separated like that, Newton's third law will be a piece of cake for you. Okay, and that's it.